Hello, in this video tutorial we will see how to implement scenarios in WEAP. The video tutorial is divided into two parts. The first one, we will see what a scenario is and the difference between reference and current accounts. We will also define the reference scenario, run the model, and explore the results. In the second part, we will create an additional scenario and explore the results between scenarios. We will also see some WEAP features for managing results, such as saving a chart as a favorite, exporting results to Excel, and viewing the results dynamically on the WEAP schematic. This video tutorial covers some sections of the scenarios chapter of the WEAP tutorial. Before moving to WEAP, it is important to understand what a scenario is and what kind of situation can be modeled using WEAP scenarios. The scenarios in WEAP seek to answer the what-if type of questions, such as what if a reservoir operation rules are altered? What if groundwater is more fully exploited? What if water conservation is introduced? What if climate change alters demand and supplies? In summary, WEAP allows you to explore a wide range of questions. To implement scenarios in WEAP, it is essential to understand first the concept of current accounts and reference. Once the modeling period is set, by default, WEAP divides the period in two: current accounts and reference. The first year of the modeling period is current accounts. For example, if the modeling period is 2000 to 2005, current accounts will be 2000. Reference will be the rest of the modeling period, in this case from 2001 to 2005. All the data are entered in current accounts. Current accounts is the base year. That is what we have been doing in all the exercises so far. We have been entering information into current accounts. Setting up current accounts is the first step for implementing scenarios in WEAP. The scenarios are created from current accounts. By default, reference is considered the reference scenario and depends on current accounts. Because reference depends on current accounts, WEAP assigns the same expressions from current accounts to reference. Reference inherits the expressions because it depends on current accounts. If no expression is changed in reference and the information is only entered in current accounts, reference will represent the evolution of the system in the modeling period without any intervention. Reference will be the scenario what if no information changes and the historical condition and trends are maintained. By default, WEAP creates the reference scenario, but the user can create more scenarios, scenarios that can answer the what if type of questions. In that sense, the heritage of the scenario is important. When you create a scenario, you must choose the scenario on which it depends. The new scenario will inherit the expressions from the scenario on which it is based. Once the question is defined, you must identify the elements and variables to be modified according to the new assumption. For example, if the question is, what if the consumption increases? The variable to be modified is the annual water use rate. If the question is, what if a new reservoir is built? We would have to add a reservoir element first and then characterize it by entering its data. Understanding what a scenario in WEAP is, we can move on to the practical part of developing this exercise. Setting up current accounts is the first step to implement scenarios in WEAP. That is what we have been doing on this model during the video tutorials. We added the element and expressions to each one in current accounts. We can set up the reference scenario now. First, we will define the modeling period between 2000 and 2015. We will change the annual water use rate for the agriculture demand in the reference scenario. It will decrease following this behavior. We will also change the population growth rate of Big City. It will no longer be 1.75%, if not 2.2%. Besides, we will use the growth function to project the population. Remember that all these changes must be made in reference. Go to WEAP. Those who have not followed all the videos in order and do not have the model in this state can follow this video tutorial by downloading the O5 Basic Tools folder. Close WEAP and double-click on the SEI training model to open the model. Go to the WEAP Basic Tools version. Area, revert to version, WEAP Basic Tools. On the right is the information that we will use for this exercise. We are going to change the time horizon first. Go to General, Years and Time Steps. Set the current accounts year as 2000 and the last year of scenarios as 2015. Remember, the time steps per year are 12 because it is a monthly model. There are two ways to create, copy, delete, or rename scenarios. In the schematic view, go to Area, Manage Scenarios. The Manage Scenarios option is only available in the schematic view or the data view. You can also enter the Manage Scenarios window by going to the data view. The option is at the top. The reference scenario will no longer represent the system under the same conditions entered in current accounts, because we will make changes to the expressions in the reference scenario. It is important to be able to trace the changes we made and what conditions represent each scenario. In the Manager Scenarios window, we can add a description to each scenario. The reference scenario will now represent the same system but under conditions where the growth rate is 2.2%. There will be a gradual reduction in the annual water use rate in the agriculture node due to an improvement in the irrigation technology used. Add base scenario with a population growth of 2.2% and a slight improvement in the irrigation technology. The annual water use rate for the agricultural demand decreases year by year. Before closing, we must verify that the scenario of interest is based on the desired scenario. In this case, reference will be based on current accounts. There is no other one available now, but this changes as new scenarios are created. Close. Now, we will enter the information into the scenario of interest. In this case, reference. We need to select the scenario to be edited in the drop-down menu at the top. We will see all the scenarios that we create in the Manage Scenarios window. Select Reference. The name of the scenario appears in red to remember that you are editing a scenario. Change the information that is affected by the improvement in the irrigation technology used. In this case, it is the annual water use rate for the agriculture demand. Remember that in a previous exercise, we created the unit irrigation water needs key assumption. We also linked it to the annual water use rate variable for the agriculture node. Because the variable has a reference to that key assumption, We only need to change the key assumption expression. The expression box for the year 2000 is blocked and set to 3,500, which is the information we entered in current accounts. As we are in data for reference, a second box appears to enter the information in that scenario. By default, the expression is the same as the current accounts expression. This is because reference is based on current accounts. Selecting current accounts enables the year 2000, which is the year we set as the current accounts year, on the Years and Time Steps window. The years above the boxes depend on the time horizon. We have a model with a time horizon from 2000 to 2015. In that case, the first year will be the current accounts year, and the following years will be the common period among the scenarios created in the Managed Scenarios window. In this case, as the new annual water use rate has an annual variation, we can use the yearly time series wizard option. We select the option depending on the desired projection. We explain these options in the WEAP in 1 hour video tutorial. Select linear interpolation. Next. In this case, as there are only a few annual values, we will enter the data manually. Select Enter Data. Next. This option allows you to interpolate values considering information after the current accounts year. So the first data is logged. It corresponds to the data entered in current accounts. Enter the data. For the year 2005, the value is 3,300. For 2010, 3,200. And 2015, 3,150. We also add 0% as the growth of the last year. Once we are done, we see that the annual water use rate decreases in the modeling period. For the years where no information is entered, the value is estimated following a linear interpolation because we selected that option. Click on Finish. For the year 2000, the annual water use rate is equal to 3,500 cubic meters. And from 2001 to 2015, the values change based on the linear interpolation. This is the expression that WEAP uses to apply a linear interpolation to the data entered. As the expression is different from that entered in current accounts year, WEAP shows it in red. Now we are going to change the population growth rate for the reference scenario. In a previous exercise, we created the estimated growth rate key assumption and linked it to the annual activity level variable for the big city node. Because the variable has a reference to that key assumption, we only need to change the key assumption expression. We had set the rate to 1.75 in current accounts. We can see that it is that value for the entire modeling period on the chart. Remember, the reference scenario is based on current accounts, and unless we change the expression in a variable, just as we are doing, all expressions in the reference scenario are inherited from current accounts. Change the growth rate from 1.75 to 2.2. We see a step on the graph. In current accounts, the rate is 1.75, and for the rest of the period, it will be 2.2. We have already changed the modeling period, the annual water use rate, and the population growth rate. We only miss using the growth function to project the population. Go to the demand sites category on the tree, then big city, and finally water use annual activity level. In a previous exercise, we used the growth from function and linked the key assumptions related to the growth rate, the year of the last census, and the last census population. We will still use that expression for estimating the population for the current accounts year, which is the year 2000. However, we will estimate the population for the following years by using exponential function considering the population of the previous year. Select Expression Builder for using the function. Delete the previous expression. Go to the Functions tab. Drag and drop the growth function to the editing box. This function calculates a value in any year from the value of the previous year using a growth rate. The description also states that the function is available only in scenarios. In the example, we can see that the growth rate can be included as fraction or percentage. In this case, we are controlling the growth rate through the estimated growth rate key assumption. Go to Branches, then to the Key Assumptions category. Drag and drop the estimated growth rate key assumption. We linked the key assumption, but remember that the growth rate is 2.2%. Therefore, we must add the percentage symbol at the end of the key assumption. Finish. The expression is shown in red because we changed it. The scenario from which reference is based, current accounts, has a different expression. For the year 2000, the current accounts year, we are using the growth from function. However, from 2001 to 2015, an exponential projection will be made with the new growth rate from the value of the previous year. In summary, when working with scenarios, it is necessary to identify which variables should be modified and always verify where the information is being entered at the top under Data form. You can also use the years above the boxes as a guide. Remember that in WEAP, a scenario inherits all expressions from the one on which it is based. In this case, reference is based on current accounts. If we do not change any expression, the expression will be the same as the one we entered in current accounts. For example, the agriculture annual activity level is 100,000 hectares in current accounts, and from 2001 to 2015, WEAP assigns the same expression. We had the same expression in current accounts and reference for the big city, but we changed it, and now it appears in red. Run the model with these changes. Yes, I want to recalculate. Go to Demand, Water Demand. This will be the monthly demand during the modeling period. Select Annual Total to see the aggregated results. In my case, the graph is in 3D. I am going to deselect this option on the menu on the left. We can see that the water demand for the agriculture node decreases, as the water demand for the big city increases. This is because the annual water use rate for the agricultural node decreases annually, while the population grows exponentially. You can continue exploring the results.